The scientific community has been studying nuclear fusion for more than 80 years and spent trillions of dollars attempting to sustain fusion to no avail. While nuclear fusion promises the potential for an endless, clean, and safe energy source, controlling the plasma fusion safely has proven difficult.
Well, nuclear fusion is the opposite of nuclear fission. Where nuclear fission, you take large atoms and you smash it with a neutron and it breaks it apart to release a lot of energy. Nuclear fusion is the opposite of that, where you take light atoms and you smack them together and then they fuse to release a lot of energy. But there's a third way called the Quantum Kinetic Well. We call it safe nuclear.
While trillions of private and public dollars have been spent on nuclear fusion devices, none have successfully proven to sustain nuclear fusion longer than 22 minutes. Nuclear fusion is proving to be quite difficult to control.
Well, it isn't anymore. What we've been able to do is create, through the modular reactor that we have, we call the ARC reactor. We've been able to take limited input power and take it to massive output energy. And we call that process the particle oscillations as an energy generator.
The academic community and the hot fusion industry, they are using light gaseous matter like hydrogen and deuterium and helium, and they're spooling them up into a tokamak, which creates a lot of heat and it's called bulk ion heating. And it takes the plasma and excites it to a heated temperature, and then they use magnets to confine the plasma that's heating up. And all these processes are complex. It's like teetering a ball on top of another ball. It's really challenging to keep it on top. It's like stacking stones. It's tough. You gotta be just right.
Hot nuclear fusion, which utilizes bulk ion heating, is inherently dangerous and expensive due to the excessive fast neutron flux it creates, making it extremely electrically expensive, ultimately keeping a viable method far out of reach.
The techniques used are destructive, innately destructive. And what they have attempted to do to mask the failure is to build sturdier equipment. And so we are finding that while one company has been able to sustain nuclear fusion for 22 minutes, they actually have destroyed their equipment in the process. You cannot repeat this over and over expecting a different result. It's not going to change the fact that that's all they have to work with.
It's very expensive, the bulk ion heating, and it's very challenging to make it happen consistently. Where in our process with safe nuclear, we use Mother Nature's fundamental forces to induce the well, and it happens 100% of the time.
The cold fusion is going to be better because hot fusion, you have to do it at really high temperatures. You have to have really large buildings. You look at the hot fusion type places, they're in giant warehouses, where our cold fusion devices, they're tabletop, they're size of a paint can potentially. And so we believe that doing it at lower temperatures with lower heat inputs, lower electrical inputs, that's going to be better for sustainable energy versus some of the hot fusion stuff where the sustaining of that is a little bit questionable.
So when you talk about cold fusion or hot fusion, you have to put energy in. And so you're either going to put in cold energy or you're going to put in hot energy. So if you think about it, hot energy is like the sun or hot plasma. And that's very difficult to come up with, or it can be very dangerous. It's been done. And so we know it's been done, but it's difficult to do.
Now, with the developments in science and technology, has rendered a new research-verified isotope editing machine that will reimagine the possibilities of sustained nuclear fusion.
The runaway effect, or the Townsend runaway effect, is really talking about runaway electrons. And so we didn't see that in any of our experiments, yet we were still able to form, transmutate radioactive atoms, or another way to say it is to edit the radioactive isotopes.
Safe nuclear fusion does a thing called transmutation, where it takes the atom and transmutes the nucleus into something new. So it turns a proton into a neutron, or even a neutron will turn into a proton. And this is called quantum thermodynamics. And if you turn on our reactors that don't need a vacuum chamber, they don't need high pressure, they don't need lots of electricity, You can change and transmutate the ambient air that has CO2 in it and transmute it into something else.
By creating a synthetic version of this dynamic quantum kinetic well process, the ARC reactor technology can control and vector Mother Nature's atomic cleaning process safely for a wide range of industry applications.
But in our process with safe nuclear, we induce this thing called cold neutrons. These are like 1 electron volt neutron vibrations that occur in our reactors, like the ARC reactor. So we have figured out a way to induce and vector, control the nuclear fusion reaction on demand by just turning the knob.
This technology is so groundbreaking because in attempts to do nuclear fusion, no one has been able to take the simplicity of what we've been able to achieve and turn it into something viable. We are very certain that we have a future that everyone would embrace because this technology will do exactly as we're promising.
The pollution-fighting ARC reactor technology is poised to usher in a new era of safely sustained nuclear fusion for industry, including innovative radioactive wastewater treatment techniques through the world's first isotope editing apparatus.
And we found with our research that if you use seawater, we can create a fine dust powder that is a hydride. It's a carbon-dense nitrogen-oxygen hydride, which is the most powerful hydride in the universe. And the Department of Energy is really interested in getting this material, but they don't know how to synthesize it. To synthesize it, you have to use a particle accelerator. We use microparticle accelerators to induce this type of reaction to get this sediment, which is useful in industry. You can use it for running cars, for getting hydrogen. You can use it for magnetic substances, for particle accelerators, new types. And there's a whole host of different phenomena that occur with safe nuclear fusion.
But we also understand that this is what the people in the future need, our planet needs. We're bringing something that is a remediation for the mistakes of carbon emission and nuclear waste.
By utilizing the patented, trademarked, and research-verified Quantum Kinetic Well's approach to atomic transmutation, the applications of the technology are only limited by the imagination.